So in this video we're going to work on our problem solving. We're going to use a bunch of equations, and I'll write them out here. We're going to use the fact that the kW, which equals 1.0 times 10 to the minus 14th, is equal to the acid concentration times the OH minus concentration. And we get that from the autoionization of water. The other three equations that we're going to use is that the pH equals the negative log of the acid concentration, the pOH equals the negative log of the base concentration, and that the pH plus the pOH is going to equal 14.00. So in the first question, we're asked to calculate H3O plus if the OH minus concentration equals 1.0 times 10 to the minus 3. So what I know is the OH minus concentration, and I need to solve for the acid concentration, and our first formula involving kW works out nice for this one. So kW equals the acid concentration, and again, hydronium ion and H plus we're going to use interchangeably. OH minus concentration. Okay, so I'm looking for this. I know what kW is. I know what the OH minus concentration is. So I could just solve for the one that I want. So the acid concentration is going to equal the kW divided by the OH minus concentration, and that equals 1.0 times 10 to the minus 14th divided by the 1.0 times 10 to the minus 3, and we're going to get 1.0 times 10 to the minus 11th for that. So in this problem I'm asked to calculate the OH minus concentration if the acid concentration equals 0.2. Again, I could use my kW expression, so kW equals the H3O plus concentration times the OH minus concentration. And again, I know my kW, I know my acid concentration, and I could solve for my only unknown, which is the OH minus concentration. So if I do that, I'll get the OH minus concentration equals kW divided by the acid concentration, which equals 1.0 times 10 to the minus 14th divided by my 0.20, and I wind up with that equal to 5.0 times 10 to the minus 14th. So in this problem I'm asked to calculate the pH and the pOH for the following. So if I know the OH minus concentration, I can use the fact that the pOH is equal to the negative log of the OH minus concentration, which equals the negative log of 1.0 times 10 to the minus 4, which equals 4.00. Remember, with sig figs, we get an extra sig fig from this. We get one number from the exponent. We get one number from the exponent, and we get the two decimal places from this digit in front of it. So those two sig figs become these two, and the exponent becomes the number in front of the decimal place. So that's what my pOH equals, and I also know that the pH equals 14.00 minus the pOH. So this equals 14.00 minus 4.00, and the pH turns out to be 10.00 from that. Okay, now I have the acid concentration. So I know that the pH equals the negative log of the acid concentration, which equals the negative log of 1.5, and that turns out to be pH, which equals negative 0.18 after you crunch the numbers. Okay. Now, using the formula that the pOH equals 14.00 minus the pH, which again is just a rearrangement of our original formula, I get 14.00 minus 0.18, and that turns into a positive, so the pOH in that case is going to be 14.18. Okay, so now I'm asked to calculate the acid concentration from the pH. So if the pH equals the negative log of the H plus concentration, if I just rearrange this, wind up taking the anti-log, so the acid concentration equals 10 to the minus pH. So this is just rearranging that equation I have. I'm bringing the negative sign over on this side, and I'm taking the anti-log of this to get the H plus concentration, and the anti-log is taking it, raising it to the 10th power, so I have 10 to the minus pH as my formula. And if I do that, my acid concentration is going to equal 10 to the minus 5.23. And when I crunch that into the calculator, I'm going to get 5.9 times 10 to the minus 6 molar. And in this case, since we're taking anti-logs, we actually lose a sig fig. The digit in front goes towards our exponent, our placeholder, and the two digits after the decimal place become our digit in front of our scientific notation. And the last one is asking me to calculate the acid concentration if I have the pOH of 1.95. So this is something I could take the pOH and solve for the pH. So remember that the pH plus the pOH equals 14.00. So the pH equals 14.00 minus 1.95, which equals 13.05. And solving for the acid concentration, the H3O plus is equal to 10 to the minus pH, which equals 10 to the minus 13.05, and I get 8.9 times 10 to the minus 13. Remember, the two digits after the decimal place become our two digits before the scientific notation, and this exponent comes from our number here before the decimal place. And there you go.